Okay, let's try solving for some variables here in these triangles using some of the things we learned about similar triangles. So what we want to do is find x and y. That's two variables in this picture here. And let's see. Let's talk about these triangles and what we know about angle. Well, I'm going to highlight two triangles in here. We have the blue one and we have the green one. And right now, no one's telling us they're similar. No one's telling us they're congruent. We have to kind of analyze the picture here, meaning there's an arrow here and an arrow here. That's telling us that these two lines are parallel. And so in order to use angle to get these two triangles to be similar, for example, we have to see these two parallel lines and then notice that angle 2 and angle 1 are congruent, and that's because of chapter 3. Those are corresponding angles. And then also angle 4 is congruent to angle 5. They're corresponding as well. So right now in the blue triangle and the green triangle, we have what we call angle. Therefore, these two triangles are similar. We also have a third angle in here that is actually shared in both triangles. So again, we don't need angle. We just need two angles, because if you have two, you're automatically going to get the third. So what I would like to do here, in order to solve for x and y, I am going to just take a few moments and redraw the two pictures. Because I know when you redraw the pictures and relabel stuff, it's much easier to see what proportions to write to solve for x and y. So when I rewrite and redraw the blue triangle, I got a 3, I got an x, and that's a 7. That's a 7 right there. And then what is the length of this side? Well, 3 plus 5 is not 15. That is, excuse me, not 15. That's 8. Because 3 plus 5 is 8. On this side, this is not 8x. Be careful, this is 8 plus x. And then on the bottom here, we have a y. So when we go to set up a proportion now to solve for x and y, what we want to do is we want to look for any two sides that we know that correspond to one another. So in this case, when I look at 3 and I look at 8, I know the lengths of both of those. So I'm going to use that as kind of like my foundation, how I'm going to compare these two triangles. And I'm going to say 3 is to 8, and that's proportional to x all over x plus 8. And so when I say that, now I can solve for x. And then I'll be halfway done, because I want to find x and y. So when I cross multiply here, that's going to be 8x equals 3x plus 24. Notice I used the distributive property here. And then I'm going to say 5x equals 24. X is 24 fifths. Another way, that's 4.8. So both of these forms are acceptable right here. As our answer, we have 4.8 or 24 fifths. And now we want to do that same madness of setting up a proportion to solve for y. How are we going to do that? Well, that's going to be what? 3 over 8 is proportional to 7 all over y. So once again, we cross multiply. That's 56 equals 3y. I divide both sides by 3. And I think this is going to be what? 18 something maybe? I'm trying to dig out my calculator. 56 does not go into, 3 does not go into 56 evenly. And so, what's the answer? This is going to be 18 and 2/3, otherwise known as 18.6 repeated. So there we go. We just solved for this picture here involving two triangles. No one told us they're similar, but we did discover they're similar using angle. Let's try one more solving problem in here. So in this picture, again, we have two triangles. And I don't see any parallel lines, but I see a much easier route. This angle, they're telling us, is equal to that one. And they're telling us that this angle is congruent to that one. Therefore, what do I know? These two triangles are similar because of angle. And so now we can write a proportion to solve for x and y. So notice the 5 and the 10, they correspond to each other. The 8 and the y, they correspond to each other. And the 18 and x, they correspond to each other. Well, the one set of sides that I know everything about is this one in here. So maybe you could try doing this in your head if you understand the scale factor technique. and seeing how things are going to get doubled in here. But if you set it up old school, I'm going to say 10 over 5. 10 over 5 is proportional to 18 over x. So when you go to multiply here, this is going to be 10x equals 90. X is what? 9. That kind of makes sense because 5 is half of 10 and 9 is half of 18. And notice this one's not going to be 4. This is actually going to be 16. The reason why it's 16 is because the larger triangle is actually bigger. So in this case, if I were to set it up, 10 over 5 is proportional to, notice I don't put the 8 on top. Because if I'm starting with the 10 over 5 is proportional to y over 8. I'm going to cross multiply in here. 80 equals 5y, y equals 16. So again, we found for x and y, and we used the fact that these two triangles are similar based upon angle. Okay, let's take a little break.